Baran. In this tutorial I'm going to show my way of cancelling the ambient occlusion shadows from albedo map. To do this I'm going to use Substance Designer and the cliff texture I scanned recently. So the material, which is properly made and wrapped around the geometry, makes that geometry real, adds detail and more depth to it. The material which has lighting information left on albedo usually feels off, and since its response to the light is wrong and physically incorrect, it breaks entire visual immersion. There is many ways to avoid shadows during the capture. We can shoot during a cloudy day, for example, or shoot surfaces hidden in a shadow caused by environment like buildings or cliffs, or even use something like light reflector to cast our own shadow on surface we capture. All those techniques are going to help us mostly with direct shadows. Unfortunately, even if we avoid direct shadows there, for deeper surfaces we still get secondary shadows, which are called ambient occlusion shadows. Those shadows are caused by lack of light and can be found in gaps, cracks, corners and any types of concaves where standard light struggles to get. I used Metashape to reconstruct the wall and turn it into high poly geometry. After that I made a low poly model in ZBrush and I baked PBR maps using Substance Designer Baker into a set of 4K PBR texture. And here we are with set of our baked textures. We've got roughness map, normal map, we've got the height map, ambient occlusion map and albedo map. And our main target right now is to remove all those shadows from the albedo map. And we are going to do this using Substance Designer. Here it is. And so let's bring those maps here. They are. Now let's plug them into outputs to get it preview in 3D. Roughness into roughness, height map into height map, normal map into normal map. We don't have ambient occlusion, so let's create one. Let's set the type as ambient occlusion. Let's update the preview. Here it is. We don't have metallic, so let's create uniform color to fill that information. Okay, and let's push all those maps away to get a clean view. So our main target is to remove ambient occlusion from this map and have it clean and good to use on this one. So to do this we will use ambient occlusion map. Because ambient occlusion tells us really where all those dark gaps are and how strong they are. So the plan is to use it as a mask. Substance Designer itself has a node to do this job, but it doesn't work very well. Let's try this one. It's called Ambient Occlusion Cancellation node, and it gets color as one input and ambient occlusion map as the second one. And it has slider which sets the power of ambient occlusion cancellation. So right now it's set to 0.25 And as you can see, we've got a lot of glitches visible in here. If we will move the slider higher, we are removing shadows, but we are just making those glitches more visible, and this is not the best solution. And this is why I was trying to find a better way to make it. So let's delete this one, and let's equalize the albedo. So the main idea is to create texture which has no dark spots and blend it together using ambient occlusion as mask with the basic one. So to do this, let's bring color equalizer node, and what this node simply does, it just flattens the color. So let's preview this one. It just flattens everything. So the lower we are, the more flattened it is. If we go totally to the left, you can see it was flattened into one single color, and definitely this is nothing we wanna get. So let's keep it a bit higher, like 0.3 in this case. And as you can see, we still have those glitches in there, so this is not the best node so far. Not the best alone. So right now let's blend this one with this one together using blend node. So let's plug albedo in a background and equalized one in a foreground. And let's use ambient occlusion as an opacity mask. So we need to invert the ambient occlusion using invert grayscale node. And let's plug it into opacity. So as you can see, this is the version with shadows, and this is that one affected by color equalizer. And you can see it doesn't work very well because there's a lot of glitches on color equalizer itself. So to improve this technique, I did another thing. So what I've done, I bring the 2D transformation node and I plugged the result I had so far and I blend it again together, and I used the ambient occlusion again as a mask, and as you can see there is no difference. But what I've done, I used the transform 2D nodes functionality. So as you can see, as long as we don't scale it, we can just offset and move the albedo around. If we move it the way that our dark spots are covered with non-glitchy information, in the result we are getting information instead of glitches in all those dark spots. So let's see the difference. This is the dark spot before and this is the dark spot after. You can see it's way better. Let's pick another one. This one. This is the dark spot before and this is the dark spot after. So as you can see, we've got nice clean albedo map with all shadows removed. So just as a summary, what I've done in here, I picked two maps which are baked. One is the albedo and one is ambient occlusion, and I use ambient occlusion, inverted ambient occlusion as a mask, and I blend albedo with version of albedo without shadows. And with the first approach I removed shadows using color equalizer node, but it wasn't enough, and the second approach was to blend those nodes together again, but I used the hack really with transformation to the node, so I shifted entire color the way that black areas were covered with something which has real information, and I blend the result together, and in result I received nice albedo map. Hope that covers everything and someone will find it useful. Thank you guys for watching and see you next time. Bye!